All right, so what is the washer method? It's the same thing as the disk method. The only difference is what is a washer? I mean, I know you know what a disk is. A washer is, that little thing you might see at the hardware store. So it's going to look like a disk, like a coin. But the middle is actually going to be cut out of this, right? So that's a washer. It's a disc with a middle cut out. So can we still do this? Can you stack up a bunch of washers and can we integrate them as this dx approaches 0? Yes, we can. Let's think about how to get the area of this, or excuse me, the volume of this. So there are, we would take the radius or the area. I keep saying area, I'm sorry. We would take the volume of the entire thing. Well, what is the volume of the entire thing? Well, there's two radiuses. There's a radius from the big radius, which is the radius here, and then there's a little radius, which is the radius there. And when we say big radius and little radius, I'm just going to use big R and little r. I know it's kind of hard to see, but let's kind of do the volume here. So it's going to be, we're literally going to get the volume of the big disk, and then we're going to get the volume of the little middle section and subtract them. So pi big R squared height minus pi R squared height. So if we were to kind of simplify this, volume equals pi so I factored out the pi. I have R squared height minus R squared height. And that's kind of what we're going to do, just like before we took the pi out front. Okay? Now we can't actually just subtract the radiuses and be done with it because you're not going to get the washer. You would just get a smaller disc. So you actually do have to keep them separate and square them separately. You can't just do that. Anyhow, let me give you a lovely example. Let's look at the square root of x and x squared. So (1, -1, and 1). Okay, so the square root of x goes like this, and it goes to the point 1, 1, and then x squared goes like this. And you can see there's a solid that's created here. Now if we wanted to mimic that down here, we would kind of go like that. But instead of having full discs, they're going to be washers. So it's going to create a solid. But the solid is going to be like hollow on the inside. So we have to subtract that inside part. So when we go to set this one up, we're going to see as so the volume here is going to equal pi. We're going to go from 0 to 1. And then in here, it's going to be big R. And big R is the outside one. So that's the square root of x. That's this one. So the square root of x squared minus little r, which is this one, x squared, and then your dx, which is your height, oops, sorry, your dx just goes out there a little bit. All right, hopefully it's not so bad. Anyhow, simplify and solve. Definitely not too bad. Volume equals pi from 0 to 1. This is going to be the square root of x squared is just x, and minus x squared squared is x to the 4th dx. That's easy to integrate. So volume equals pi. I'm going to raise the power by 1 and then put and that makes it 2, and then put the 1/2. 1/2 x squared minus 1/5 x to the 5th. Oops, I don't need that anymore because I integrated it from 0 to 1. Okay, and now I just plug in some values, and we get ourselves an answer. So the volume here is, let's see, pi, I'm going to plug in 1. 1/2 times 1 squared is 1/2. 1/5 times 1 squared is 1/5. So I plug in the 1, that's what I get, minus, let's plug in the 0. 1/2 times 0 squared is 0. 1/5 times 0 squared, times 0 to the 5th, whatever, it's still 0, it doesn't matter. Okay. So you can see this whole part just kind of cancels. 1/2 minus 1/5, this is 5/10, minus 2/10 is 3/10. So this entire answer will end up being volume equals 3 pi over 10 once you go through and figure it out. If you've noticed, all of your answers for the most part will have a pi in it, unless something happens that the pi cancels, but you're going to end up with a pi for the most part. Okay, this is the washer method. Not so bad. You do just kind of have to, you just have to kind of be careful with it, and just make sure you kind of follow the formula. You square both radiuses and then you subtract it. You integrate the whole thing. But it's very similar to the other one. It's just a matter of setting them up. The integration you guys will be able to do. So let me give you one or two of those. So, same page, on page 428. Page 428. I want you to try a couple of those. 5 is one that I want you to try. And I would also like you to, just number 5? Yeah, just number 5. That's fine. No big deal. All right, let me know how it goes. Just like before, please ask me if you're stuck. Thanks.